Hey guys, it's Emac here. Today we're going to talk about how to be a pragmatic programmer. So I read this book many years ago, but I thought it's a great idea to share with you guys what I've learned from this book because it's one of the books that if you're a software engineer, it's a must read for you. But I'm going to give you a very short summary so you guys learn what Andrew Hunt and David Thomas talk about in this book, The Pragmatic Programmer. So the first thing you need to understand is they're talking about a very good concept, and it's like don't live with broken windows. So it means when you have a bad design, when you have a wrong concepts in your application and you have a poor code, so you have to live this forever. You have to maintain it, you have to add feature, and you have to fix bugs all the time. So don't do that. What they're telling us is fix the code and make it a high quality code so you don't have to live with broken windows all the time. So the second thing they talk about is about stone soup, and when you put the frog in the boiled water, it will jump out. But if you put the frog in cold water and start heating up the water, then that frog won't realize that the water is getting warmed up. So don't be like the frog. This is a very actually good tip in real life example. Sometimes we leave it legacy applications, we have to maintain them all the time, and I've been there, I've done it many times. The third tip is always remember the big picture. Sometimes perfectionism and looking for the perfect solution, we get stuck with a lot of details, and we forget about the big pictures. We forget what the main goal is, what we need to do in order to finish the project. We get stuck with really small concepts, and we never get to finish the project. That's one thing you definitely need to understand. Make quality your priority, and basically make it requirement. If you have a lot of duplication in your code, that's a very bad sign. You always want to make sure you keep one version of any function, any method in your application. And when we don't pay attention to quality of a software when we're writing applications, in the short term, it doesn't seem that bad. But in the long run, when you have like thousands of millions of lines of code, and different people joining different things, they sometimes they test different features, they just leave it in the code. Those are bad things. So code review, of course, it's a process that helps you or helps companies to basically make sure they have a high quality software. So make quality a requirement. That's 4 point. The fifth one is know when to stop. So sometimes we start building features, applications, and we never stop. We just keep going forever. So that's one part of usually engineers. That's what they do. They just keep going on, and this is not a good thing, because you need to know when to stop when the project is done, and then you have to market it. You have to make money with that application, or you have to kind of deliver it to the final user and then wait for the feedback and then move on. The next one is invest regularly in your knowledge. I actually have a few videos that I definitely recommend you watch that. I have it in the description, and basically I tell you all the good investments, and one of them is how to invest in yourself, and because in the long run that's the biggest investment you can benefit from. Critically analyze what you see and what you read and what you hear, because sometimes we don't pay enough attention to actually the facts, and we start following people's opinion, and there's a lot of confusion. So don't believe everything, and then do your investigation. Make sure as an engineer or as a person you understand all the different aspects of a problem, because your job as a software engineer is to remove ambiguity. That's your job. The next one is communicate. Non-technical people, they always have trouble communicating with software engineers, because sometimes engineers only look at the technical aspect of a project, and it's hard for them to kind of be out of that 0 and 1 box and mindset and start thinking about business problems. Always get back to people, even if you don't know the answer right now. This is how I usually do it. And when people ask me a question, even when I know the answer but I'm not 100% sure, I want to check with my team, or so always tell people, hey, can I do a little bit of research and get back to you? Is that okay with you? So when you say that, people always count on you. They know you take responsibility. You are a good listener. You don't jump into conclusions, right? Don't jump into conclusion immediately, because that doesn't send a good signal to the other person. It means you're not listening properly, or you're not a good listener. The next one is about duplication. Duplication is your enemy. Number one enemy in software development is duplicated code. And then how does it work? Why we end up having a lot of duplicate codes in our applications as a team? And the reason is sometimes developers, they are lazy. I'm sorry, and they think, oh, I'm just gonna just copy it. I don't want to, build a nice pattern like abstract factory design pattern, so I can basically have a lot of flexibility, or they copy the code and they just keep using the same version over and over in different classes, and that makes the code really, really messy. The other one is multiple people, they work on different pieces, and then at the end they bring the code together, and you see a lot of duplicate codes. They all use a same model to connect to database, but you have like 50 different connection strings throughout your application, which is not good. Because if you want to change the data source, if you're building a highly available application that needs to connect to a separate database in terms of when a disaster happens, so you have to update 50, 60 connection strings, which is a very, very bad thing. Sometimes programmers don't realize that they're actually duplicating the code, and it was like, no, this is a different function. But one thing that I can tell you definitely you need to invest in is design patterns, right? Design patterns like Gang of Four, they have a very good book that basically they introduce you how to basically understand the patterns and make use of them when you're developing your application. Because when you see a pattern and then you want to implement it in real life, then you have it you can connect the dots, and you can, oh, this is the pattern that I've learned in this book, and I can now make use of it here. So definitely I recommend invest a little bit of time and learn about design patterns, because that way if you're duplicating code, you can tell your colleague, hey, I think we can actually make use of this pattern, and then we remove the duplicate codes. And the next one is sometimes they just don't know, and they think that's the only choice. They have no choice. They have to duplicate codes. But again, duplicate code, it's very, very bad, and it's probably your first enemy. If you don't pay attention, it will keep growing, and it will become a disaster at the end. Maintaining it will be really, really difficult. The next one is putting comments in your code. So even a lot of programmers, when they write code, they make it somehow hard so other people don't understand the code. That's a very bad habit. If you see something like this, try to talk to the person. It's like, hey, can you, next time when you put submit code, or you send us a code, or you write something, put more comments. Put as much as more comments, better, right? Explain what you're doing, explain all your thoughts, all the examples, and all the data set that you've tested. Put everything in the code, so make it easy for other people to understand your code. Making it hard for other people doesn't make you a better programmer. We make it easy to reuse the components. So if you are if you're familiar with object-oriented programming, you know what I'm talking about. Make components. If you're, for example, writing a Java application, definitely make use of abstract class interfaces and basically inheritance and all the component encapsulation and things like you've learned in object-oriented programming. I do have a video about mastery in object-oriented programming. Make sure you watch that. So making components, or even if you are building a React application, in React we build different components, and then we can reuse them in different places in our application. So components basically help you build really loosely coupled application. So in case something breaks, you can just fix that piece. You don't have to, refactor or redesign the entire program. The next one is orthogonality, and this is a very actually good concept. Let me tell you what that is. So imagine a radio, right? When you change the volume, you don't want the station to change, and vice versa, right? So basically, you don't want this effect in your program then when you change something and affects other things. So always think of orthogonality and make things that unrelated things that they're not supposed to affect each other, like the volume and the channel in the radio. Remember that example. Keep your code always decoupled, right? Loosely coupled applications, it's a great thing. For example, when you're developing Java application like Spring, Spring is actually dependency injection and IOC, inversion of control. And IOC is basically, it's the same thing. It helps you to make loosely coupled application because that's the main goal in application development. Imagine you have two components, you have payment component and you have card component. If they are tightly coupled together, if one breaks, it will break the other one, right? If your search function is tightly coupled to, I don't know, the other function on your website, so these two, if one breaks, it will break the other one. So make sure your code is always loosely coupled, not tightly coupled. So avoid global data, because global data, it can be really dangerous in big applications. You, for example, update part of the information in global data, and since it's global, it will affect everything in your application, and that's a very, very dangerous thing. So make sure you understand scopes and how scopes work in your application. When you're changing one variable, it's going to affect other places. So make sure that doesn't happen to you. The next one is, so we already talked about comments, but basically when we make changes to software development, we have to keep the comments, and underneath we have to update, because that's the knowledge. You have to update the comments, and basically if you are maintaining a code, you have to also maintain the comments, because you have to make sure the right comment based on the date is on top of the function, and it explains why you changed this, application, why you changed this variable to work with this data set like the way it is. So make sure you always keep your comments updated. The next one is sometimes people just start building projects without trying out different things. So always start with MVP, minimum viable product. I'm going to have a separate video on this and tell you how you can actually benefit a lot from building an MVP. But for now, prototype as much as you can. Build something very small, see how it works, experience, and see if there's a better way to actually, continue this program in a better, take it to the better route. But sometimes programmers, they just get stuck with one way of programming. No, this is what I know how to do it, and I'm going to do it for the rest of my life. So have the flexible mindset of like, okay, I'm going to, practice and prototype. I'm going to have a very small model. I'm going to make a few days. So I'm going to spend a few days and learn about it and see what I can do with it. The next one is estimate to avoid surprises, right? Surprises always, like, they'll happen, crashes will happen, disasters will happen. So you have to be prepared, but you can minimize those by, thinking about, worst case scenarios always. When you're building something, always think about, okay, how can I reduce the, risk in my application? Think about things that can go wrong, because they will go wrong one day. So the next one is always use source control. I have a separate video on AWS code commit, and I show all the Git commands. So, that's all you need to learn about, source control. Watch that video, definitely will help you, control your source. Basically, source control is a place that you submit your code, and it keeps track of all the changes in case you want to go back, and whoever makes changes to your application, it will keep it in a separate, streamlined, very, very, awesome tool. Definitely make sure, check that video out, and I'm sure you will like it. So fix the problems, not the blame, because sometimes in teams, people start blaming each other. Oh, this is not our product. This is, team whatever. Go and talk to them. So try to work with people, because again, as a software engineer, your primary job is to remove ambiguity and problems. So have a debugging mindset. Sometimes when things go wrong, people start panicking, like, oh, what do we do now? No, keep calm. Make sure you have all your document. Just start looking at the code and try to figure out how you can make it happen. So when you're debugging, when there's a problem in the application, don't panic. You will definitely be able to find the problem if you stay focused on the issue. So always visualize your data. That's a very, very good thing. So a lot of people, when they start writing an application, they just start typing they're thinking about the syntaxes and the things that they need to implement. But if you visualize your data, right, imagine you're moving a bunch of data from point A to point B, and they're like, okay, so we're transferring, with in JavaScript, we're transferring, I don't know, 300 properties from this application to this application. That's not a big deal. But they don't think about it. What if I have like 100,000 users running the same thing? So always try to make a snapshot, make an image of your data, visualize your data, because that helps you to make very, very good decisions in terms of data structure and algorithm. So crash early. Learn to crash early. If something is wrong, let it be wrong, and you will fix it, right? Don't hide it. Crash early. If you know something is bad, bring it to the surface, and hey, here's the problem. We need a solution for it. So crashing early will make your learning process faster. You can basically come back and recover faster. But if you keep it hidden, it's going to be a problem in the long run. So we talked about loose coupling and tightly coupled applications. Always look for loosely coupled architecture. Well, dynamic configuration. This is a very important point. So some people, they just integrate and they hard code things in the application. If they're calling it, I don't know, a outside service, they always hard code that address of that server in the application. And some people, they hard code password, username, and then later they submit it to GitHub and they share the password with the rest of the world. So you don't want to make those mistakes. So always keep the configuration outside the application. And at the runtime, when the application loads, you can actually load the configuration from a file that separately you keep it outside the application. Those are configuration files. For example, in Spring Boot, you have application.property, or you can create different property files. You can set all the connections, all the values that you want to inject into application. If you're writing multi-language application, you can definitely set that up. So don't integrate, right? Don't integrate. Always configure. When the application loads, you can read the values from outside. At one point, they talk about MVC concept, model view controller. As you guys know, model is a data, controller that's how you navigate the application, and view is basically whatever view you're using to represent your data. So always keep those separate, because if you change the view, you don't want to affect the controller or the large business logic side of your application. So, or if you change something in business logic, you don't want that to be affecting your view. So always keep those separate. It's a very common practice, and we all know that. So big O notation. A lot of people, they think big O notations are only for interviews, or it's just theory. But to be honest, big O notation, it's one of the most important things that you need to think about as you're developing application. Big O notation is very, very important concept, and it's so easy actually. If you think about it, when you write a for loop in your application to repeat the same thing, yes, but if you have like 10 records, or if you have 100 records, it's not a big deal. If you iterate over and brute force all the data set, it's not a big deal. But what if your data goes to 1 billion, right? So then efficiency becomes an issue. So as your data grows, the time that your application requires to run that algorithm becomes a really, really critical point. And then you need to pay attention as your data grows in your application, how your application performs. So the way we measure the efficiency of an application, it's called big O, or complexity analysis. So for loop, for example, let's say you have a for loop that goes from 0 to 10. So that's 11 times, right? So basically, as your data grows, the time grows. That's called linear, right? I want to give you a real life example. Driving between San Francisco and LA, right? And then, so let's say distance and time. Let's say it takes 7-8 hours, from LA to San Francisco. What if you want to go to Seattle? So if you increase the distance, it will increase the time. I hope this makes sense. That's a linear relationship between time and distance. So we have nested loops, right? Sometimes we have 2 for loops with one loop that's within the other one. So that makes it really, really bad. It's basically n squared, right? Because for each loop, the inside one will go through another loop. So that makes your algorithm to run very, very slow if you're dealing with big data, right? And basically the difference is between a user waiting like 10 minutes for your report, or if you use an enhanced algorithm, it might take like 2 minutes. For example, in search are really, good data model that you can actually practice complexity analysis, because you'll learn how different approaches can really improve the application performance. So one of them is divide and conquer, right? In divide and conquer, so we basically, if you have a big data set, you basically chop this every single time, divide it, and then you work on a smaller piece, which helps a lot in terms of performance of your algorithm. And you have binary chop, right? For example, binary search tree. In binary search tree, if you're not familiar, that's very simple. Imagine you have a node at the root, and then on the right side, you have a values that's bigger than node, right, root, and on the left side of the tree, you have values that are less than the root value, right? So imagine if you have a phone book, and if you are looking for a person that whose name starts with letter S, so all you need to do, you open the phone book and it's a middle, right? And let's say you end up opening the phone book, it's J, right? And you ask this question that where is S? Is after J or before? So S is after letter J, so that way you don't have to keep searching for all the letters before J. So this way you are chopping, you are decomposing the data, and basically you're not searching the place that is not, it doesn't have the result. So make sure you understand the complexity analysis. When you're doing binary chop, you're basically dealing with log n big O, and if you're running in and if you're working on divide and conquer, you're basically doing n log n application like merge sort. In merge sort, you basically divide data first in two half, and then you chop it, divide and conquer, and then you start sorting those small pieces, right? And then you combine them back together. So that's n log n. And so these are the things you want to make sure you're familiar. I'm going to have a separate video on data structure and algorithms, and I'm going to tell you all the real life examples of those data structures. So the next one is refactoring. Why we refactor code? When we have a lot of duplicate code, when you have a performance issue or the quality code is low, we have to refactor the code. It means we have to open the code, basically do some surgery, and then fix the broken parts or the parts that has bad for performance. If you have one class that does 100 different things, that's a very bad sign. You don't want that in your application. You want to have highly cohesive and loosely coupled components in your application. Build 100 different classes that each focuses on one thing, and it does it really, really well. That's how you do refactoring. If you're refactoring a function and you think you'll have to change 20 things, do it one at a time. Don't do 20 at the same time, because if you mess something up, it's really hard to figure out what's causing the problem. So do one thing at a time and take very short steps. That's a very important thing. If you're doing real life refactoring, you really know what I'm talking about. So always think about performance when you're refactoring. If you're refactoring part of your search algorithm, make sure you're using search functions that it's has very good performance applications. Don't use bubble sort that has the worst complexity analysis. Use something like merge sort, right? Quick sort. So outdated knowledge, that's why we upgrade our code. If part of the application changes, we have to upgrade the knowledge, and we have to do that. And sometimes orthogonality that I told you about, pieces that they're not related, they affect each other, that's a very place you have to refactor your code. Test your knowledge all the time. When you come to conclusion and you finish the application, always test your result. Write some test cases, and you run your application against those test cases and then submit the code. So we have different type of testing. One of them is unit testing. You can test one unit. Again, loose coupling and loosely coupled application. They're really easy to test because you can just look at them as one unit. You have unit testing, you have basically integration testing, that how the modules work together, and you have regression testing, which basically you can compare the result, over time, and then test your performance, and test to discover where the application was. Make sure you always test the edge cases, because there's a lot of edge cases in application, and sometimes programmer forget to test those. And test your tests, right? Make sure you have a good testing. Test your GUI, test with real life data. So I hope you enjoyed this pragmatic programmer review and summary that I shared with you. Again, I read this book a while back, maybe a few years ago, and I really enjoyed it. I always have it in my library. I thought it's a great idea to share with you guys what I've learned. Leave any comments below. I'll get back to you, and subscribe to my channel. Don't forget to like this video. I hope to see you next time. Bye.